Good morning.
I haven't started today.
Let's continue on Kirchoff laws, some examples about it. But last lecture, I told you before starting doing any analysis in this circuits, we need to determine the voltage polarities and current directions. So when you look here at this circuits, not all of the current directions are given, not all of the voltage polarities are given. So we need to assume them. How can we assume them? I already written the procedure last lecture, which is how to assign the polarity, voltage polarity and current direction. Ohm's law for the resistors V equal I times R. Our target is to make Ohm's law positive. So if we have the choice to choose the current direction and voltage polarity, we need to make sure the voltage or the current enters the positive polarity of the voltage. If we can do this, that's fine. If we cannot, then don't forget to keep in mind that Ohm's law will be negative. Okay, so basically, when we have a current from the source, we will assume the current going out from the source. So when you look at this circuits, look at Vs. So Vs here. So you will see that we assume the current going out from the source. So when I say the currents, or in order to make Ohm's law, the current must enter the positive polarity of the voltage, this will be only for the resistor. While for the source, it will be the opposite. The current must go out from the source. So here we have Vs, so Is must go out from the source. So basically, you can imagine there is a water pump, provides some water, like water pressure. So the water will be out from that water pump. Therefore, the currents will be out from the positive polarity of the voltage source. Then you can imagine that the water will flow. When it goes to resistor R1, okay. So you can imagine there is a water flow from the source. Then will keep flowing. When it goes to the resistor R1, it is the same currents. No change, because there is no point the current will be slitted. Then until reaching this point, when reaching this point, it will be slitted. So there will be a current going here, a current going here. Therefore, like you can call them, for example, I2, I3. That's how we assume the currents. While in order to assume the voltages, after making the current assumption, now I'm ready to make the voltages. Vs already given, we don't need to assume it. While for resistor R1, since the current going in the right, from left to right, then the positive, we need the current to be entering the positive polarity of the voltage. That's why we assume plus minus V1. Then look at R2 and R3. We are making sure that the current will enter the positive polarity of the voltage. Then that's it. That's how I assume all of the voltages. So again, you need to keep in mind, make sure the current enters the positive polarity of the voltage so you can avoid the negative current or negative sign of Ohm's law. Okay, that's our standards. Then, after doing this assumption, what are the procedures that we need to do in order to solve the DC circuits? So, step number 1, assign voltage polarities and current directions. That's what we did. Assign voltage polarities and current directions. Step number 2, to solve this circuit, start from the extra given information. Start from the extra given information. Sometimes when you look at this question, or any question, you will see something given. So start from this given in purpose. So this extra given information can be either voltage, currents, or it can be power, or any other values. Voltage of a certain element, power of certain element, current of certain elements. Then, step number 3, when you do your analysis, look for only one unknown in KVL, KCL, Ohm's law. So after you start from the extra given information, you need to apply one of these three, KVL or KCL or Ohm's law, such that there will be only one unknown. If there are more than one unknown, then this is not the right way. Look for another way. So we don't want to apply KVL and KCL such that there is only one unknown. Okay? I'm sorry, that's such that there is more than one unknown, like 2 unknowns, 3 unknowns. This does not apply, but we need to have only one unknown, then we can do our analysis. So by following this procedure, we can solve some circuit analysis, like DC circuit analysis. So now let me go to the example. Okay, let me give you a few seconds to write, then we'll go to the example. Okay, here's the example. Before doing any analysis, we need to assign a voltage polarities and current directions. So look here at this circuit. We will assume a current going out from the source. In this circuit, we have two sources. We have voltage source, current source. Which source would you like to start? Whatever you want, that can be fine. So most likely, by looking at the upper source as an example, which is voltage source, we will assume the current going out from the source. So this I'm going to call it IS. Then, most likely, when the current flowing here, it will be splitted. So at this point, at this node, it will be splitted. So it will be splitted such that I'm going to call this as I0. I'm going to call this as I1. Then we have another source like IA. It's already been given the current directions. How about the polarity for that source? We will talk about this after assigning the current. So this source, we know the current is IA. It's flowing like this way. Then at this point, the current will be splitted. So I can assume a current going this way. So I will assume this as I2. Going this way, I2. Then at this point, here is IS, here is I2. Then I need to assume a current for the 2 ohms resistor. Now the question is, for the 2 ohms resistor in the left, this resistor, should I assume the current going up or down? Down or up? Actually, it doesn't matter. You can assume it either up or down. But what matters for us, which is the voltage polarity. How? Let me assume initially, I'm going to assume this goes down. So this is I3. Now, I'm ready to assign a voltage polarities. In order to assign a voltage polarities, let's start with the 2 ohms resistor here. I need to assume the voltage polarity such that the current enters the positive polarity. So, the positive sign. Since the current go down, then it will be plus minus. I'm going to call this as V3. If, for instance, for example, we assume the current going up, in case, if we assume the current going up, then the voltage polarity will be different. So it will be like, since it goes up, it will be the positive here, the negative here, V3 will be here. So look at the difference between what I wrote here and if the current up or the current down. Assume the current down, look at the voltage polarity, the positive at the top. If I assume the current going up, the positive at the bottom. That's what I say, like, it doesn't matter for assuming the currents, but you need to keep in mind the voltage polarity. So, again, the key is make sure the current enters the positive polarity of the voltage, and that's it. Okay? Does this make sense? So whenever we apply the currents, again, you are free. If, for example, you said, I don't want to assume I1 going left, I want to assume it go right. That's fine. You can assume whatever you want. But keep in mind, when you assume the voltage polarity, you need to make sure the current enters the positive. Now, let's go to the other elements. Since we assumed I2 going here, so the positive, the current enters the positive. Here is the negative. This I'm going to call it as V2. Now, for I1, this resistor, so this is plus, here is minus, here is V1. Now for 2 ohms resistor, this is plus, this is minus, and this is V4, I'm sorry, VO. Then we have the only other thing, this is the voltage of the source, polarity is given, so we don't need to assume a voltage polarity. Then we have IA, we need to assume a voltage polarity for it. In the currents sources, we will assume the voltage polarity like this every time. If the arrow goes down, then the voltage polarity will be like this. So since the arrow goes up, then the positive will be at the top of the arrow, while the negative at the tail. So here is plus minus, I'm going to call it as VA. Okay, now I have all of the voltage polarities assigned, all of the current directions has been assigned. So what should I do later, or what should I do next? According to our procedure, step number 1, assign voltage polarities and current directions. Step number 2, you need to start from the extra given information. Is there any extra given information here? Look at the circuit. Yes, we have where? 4 volts, right? So we have 4 volts given. And you can locate the positive here, the negative here. This means this is the same as the voltage at the element VO. Is this correct? Because it's in parallel. Or assume that this is the edge of the DMM, digital, or the terminals of the digital multimeter. So you put this is a positive sign, the negative sign, the readings is 4. Therefore, this is the voltage of this element. So I will say here VO equal to 4 volts. Now I have VO 4 volts. Okay, what should I do? Step number 2, start from the extra information. Now I know I'm going to start from VO. Step number 3, look for KVL, KCL, or Ohm's law such that there is only one unknown. Now, can I do KVL to find VO? Actually, VO is known, but can I do KVL such that there is only unknown, or KCL? So one of the easiest ways, apply Ohm's law into the VO. We have R, we have V, then we can find I easy, right? So I would say, let's start making Ohm's law. And during your analysis, please justify your answer. Don't just write numbers. Please write. I'm going to apply Ohm's law, like what I'm writing here, in details. So you need to write like VO equals IO over R. So IO, actually, sorry, I missed it out. IO equal VO over RO. I'm sorry, I need to make it offline. Apologize. My phone is connected to this. Then we can make a phone call in public. It's VO over RO. So VO is given as 4 volts. RO, the resistor associated with it, which is 2 ohms. Then the answer will be 2 amperes. Now I know IO. Okay, the question asks me to calculate IA. Okay, how can I calculate IA? We can calculate IA actually by doing KCL, right? Because IA is associated with this element, VA. So if I find VA, this is not enough because I cannot apply Ohm's law here. We cannot see a V equal I times R. So finding VA will not help me in this. So I need to calculate IA. What other things that I need to calculate? So KVL is only used to calculate the voltage. Ohm's law, which is there is a resistor. But here this is not resistor. So I cannot apply KVL or Ohm's law. The only thing that I need to apply, which is KCL. KCL will be applied at the nodes. So when you apply KCL, you need to look at both nodes. Look at the top node or the bottom node. So let's look at the top node, which is here. I'm going to label this node as node 1. I'm going to label this node as node 2. So when you look at node 1, we need to calculate IA. Now, do we know I1? No. Do we know I2? No. Do we know IA? No. So we have 3 unknowns. So working on node 1 is not a good idea. Look at node 2. Node 2, do we know IA? We don't know. This is unknown. Do we know IO? Yes, we do. Do we know I3? No, we don't. So even like applying KCL here is not sufficient because there is another I3 unknown. We have, two unknowns. But at least it's better than applying in node 1 because node 1 we have 3 unknowns. But now we have 2 unknowns. So the thing is, we need to calculate I3. If we can figure out to calculate I3, then we can solve the problem. Is this correct? So here I'm just telling you the way that you need to think in your mind. So you don't need to write what I'm talking about. But here I'm just giving you the skills in the way of how can I solve these kinds of questions. So since applying KCL will not help me now, let's do something else that can help me. So look for a way such that there is only one unknown, KCL, KVL, Ohm's law. Now, let's look for KVL such that there is only one unknown. So I said, in order to apply KCL for node 2, we need to know I3. So let's look at I3. How can I find I3 in this type of situation? Or the elements around I3, either I3 or V3. Can we apply KVL, this loop? I don't think so. V3, V2, VA are unknowns. Can I do KVL, these two, like this, or this? V3 is unknown, 12 is known, VA is unknown, V1 is unknown, so it's not a good idea. How about the outer loop? Can I do KVL at the outer loop? V3 is known, 12 is known, VO is known. Okay, that's it. So that's the way that I'm thinking, which is you need to look for a way such that there is only one unknown. Then I will write, again, make sure to justify your answer. We will do KVL at outer node, outer loop, I'm sorry. Start from the left bottom corner, then go clockwise. So I'm gonna start from here. So I will hit the negative sign, so it's negative V3. Negative V3. Then keep going here, negative V source, negative V source. Then keep going, you will hit the positive VO. So it's positive VO. Then keep going, no other elements. We are done with the loop. Therefore, it will equal to 0. Substitute the values. V3 is unknown. V source is given as 12 volts. VO is given as 4 volts. Equals to 0. As a result, V3 will be moving to the other side, will be negative 8 volts. Now, after calculating V3, we can actually apply Ohm's law in V3. Because if we do Ohm's law in V3, we know V3, we know R3, then we can find I using Ohm's law. Is this correct? Yes. And the good thing, which is, if I'm following the standards in the assumption, I don't need to worry about the negative sign in Ohm's law. So Ohm's law is every time positive. So I will write here Ohm's law at here is V3 equals I3 times R3. Now I need to calculate I3, which is V3 over R3. Substitute the value with the sign. So V3 is negative 8, R3 is 2, so the answer will be negative 4 amperes. So now I just calculated I3, which is negative 4 amperes. Again, my target is to calculate IA. Yes?
Do you prefer like breaking it up into KVL and Ohm's law, or could we just plug in Ohm's law into KVL and solve it straight for I3?
Yes, this actually can be as a shortcut. If you want to let's see here. Yes, you can plug it in. Right, correct. So the way that he's asking, which is sometimes, why do I need to calculate V3? How about if I substitute it like in V3 here as I3 times R3 minus Vs plus Vo equals 0, then I can calculate I3. That can be correct. Yes, that's fine. So that's every time I encourage you to justify your answer, then we can know what you are doing. Okay. Now, I calculated I3. The next thing is I need to calculate IA. How to calculate IA since I know I3? Let's go back to the circuit. I'm going to zoom a little bit here. Then node 2, IO is known, IA is unknown, I3 is known. So we have only one unknown. So I think it's a good idea to apply KCL at node 2. Again, you need to, when you write your analysis, you need to write the nodes. Where is these nodes? Or the node number. You can call it either node 2 or node A, node B, or yellow node, whatever you can call it, or something like that. But please make sure to justify your answer. So you need to write here KCL at node 2. Since here I label it as node 2, so I'm going to write KCL at node 2. And in KCL, the sum of leaving currents equals to 0. Now let's look at IO. IO is leaving. I'm sorry, it's entering, so negative IO. Then IA is leaving, so positive IA. I3 is entering, so negative I3. So plus IA minus I3 equals to 0. Therefore, IA will be IO plus I3. IO, we already calculated it as 2 amperes, plus I3, we calculated as negative 4. So the answer will be negative 2 amperes. This is IA. Then the final answer will be boxed like this way. Don't forget to write the units. Whenever you have voltage, it's in volts. Power, watts. Voltage, again, volts. Currents, amperes. So please make sure to write what's called the units. Any question about this example? Yes.
If we were to assume the current was flowing in the opposite direction for V3, how would that change?
So basically, if we assume it goes up, so the voltage will be positive. So when you do your analysis, you can try it, but I'm gonna tell you like the answer. So V3 will be positive 8 volts instead of negative 8. Then I3 will be 4 amperes instead of negative 4. Then when you do your KCL, it will be negative IO, then plus IA plus I3 equals to 0. So as a result, IA will be IO minus I3, which will be 2 minus 4, so it will be negative 2 amperes. Then both of them, IA negative 2, negative 2. So this will yield, of course, to the same answer, the same final answer. But the assumptions, V3 is 8 instead of negative 8, because now it's in the opposite polarity of V3, and the current the same. It's negative because the opposite direction. Okay, any other question? Okay, so you see this question take a lot of time because I'm telling you the way that you need to think about it, and that's what we think. But generally, this question shouldn't take 5 to 7 minutes. Okay? Let's go to this example. Now we will go fast because we already discussed the procedure. It's almost a similar way, but with more explanation, or different way. Now, in this situation, we need to assume a current directions and voltage polarities. So let's assume we start with IA. We need to calculate IA. That's what the question says. So the current will be go out. This is IA. IA will be splitted at this node. So I'm gonna call this one as I1. I'm gonna call it IO. So here is IO. Then I1, it can be splitted at this node to be as here I2, and this is V source. So I'm gonna assume the current as I source going here. Then the currents, I can assume it going here, which will make it I3. So I3, I assume it going from bottom to up, or from down to up, or going to up. But if you want to assume it the opposite way, there's no problem. Now the next thing is, which is to assume the voltage polarities. So VO given 12 volts, it's already been given. This is VO equal 12 volts because it's in parallel. Now for IA plus minus VA, this is V source, and here plus minus V3 plus minus V2 plus minus V1. Then now I have all of the current directions, all of the voltage polarities. Next step, start from the extra given information, here, which is the VO. So we have VO, we have R, then we can calculate IO easy by applying Ohm's law. So let's do Ohm's law. This will yield IO equals VO over RO, which is 12 over 6. So the answer will be 2 amperes. That's IO. The next thing, which is, remember, our target is to calculate IA. Now, in order to calculate IA, we need to apply KCL. Look at the edges of all the nodes. We have this node, or we have this node. Actually, this is node, or this node. So let me call this node as node 1, this node as node 2. By looking at node 2, we have IA is unknown, I2 is unknown, I3 is unknown. 3 unknowns, then this is not a good idea to do KCL at node 2. How about node 1? Node 1, IA is unknown, IO is known, I1 is unknown as well. So we have 2 unknowns, but it's better than node 1 because node 2. It's better than node 2 because node 2 we have 3 unknowns, but node 1 we have 2 unknowns. So that's my target aiming, or let's aim on doing KCL at node 1. But the thing which is, we don't know I1. How to calculate I1? Since I1 associated with V1, then let's try to find any way to find either V1 or I1. So let's first try to think about applying KVL. Any KVL that includes V1. We have this loop 1, we have this loop 2. So by doing this at loop 1, VA is unknown, V2 is unknown, V1 is unknown, then loop 1 is not a good idea. Here is node 1, here is node 2. I think I messed it up. This is node 2, here is node 1. Okay. So KVL was not a good idea. Then, how about doing KVL here? Is it a good idea? I think so. Because V source is known, V1 is unknown, VO is known. So we have only one unknown. That's what I want. Look for a way such that there is only one unknown. So I would say, let's do KVL at loop 1. KVL at loop 1. Start from the left bottom corner, then go clockwise. So starting here, this will hit the positive sign of the voltage. So it will be plus V source. Then keep going, you will hit the negative sign of V1. So it will be minus V1. Then here, the positive side of VO. So it will be plus VO. Then no other elements. I'm done with the loop. Then that's it. This will make it equals to 0. Now, let's substitute the value. So it will be positive plus 4 minus V1 plus VO, which is 12, equals to 0. So the V1 will be 12 plus 4, 16 volts. That's V1. Then the same thing, since we find V1, we can calculate I1 using Ohm's law. We can do Ohm's law here. Here. I1 is known, V1 is known, V1 is known, R is known, then we can calculate I1. So let's do Ohm's law by mentioning V1 equals to I1 times R1. Therefore, I1 will be V1 over R1, which is going to be 16 over 4. 16 over 4, so the answer will be 4 amperes. Now, I know I1. I know IO, so we can apply KCL at node 1 to find the answer. So the last thing then, which is basically, we can do KCL at node 1. Again, you need to write, when you apply KCL, you need to write, it's KCL at node 1. You need to identify which node. When you do KVL, you need to identify which loop. And you need to put the number on the circuit, like this is loop 1 or this is node 1, etc. So the sum of leaving currents equals to 0. Now, let's look at these currents. We have IA going this way, which is entering. So it will be negative IA. Now, I1 is leaving, going down, is leaving this node. Therefore, it will be positive because it's leaving. IO is leaving. It goes here and leaving. Therefore, it is, since it's leaving, it is positive. Equals to 0. Therefore, IA will equal to I1 plus IO. So I1 we calculated as 4 amperes, and IO we calculated it as 2. So the answer will be 6 amperes. Then box the final answer. Don't forget to write the units, which is amperes. Yes.
So for 4 volts or V5, why is the current coming out instead of going in?
Yes, every time when you have a voltage source, you need to assume the current going out like this way. If the polarity like this, you need to assume the current going this way. Okay? So you will notice this is the opposite of the resistor. And then the same when we have a current source, you will assume the positive at the top of the arrow, or if the current source goes like this way, the positive at the top of the arrow. Again, this is the opposite of the resistor because the resistor is absorbing power while the sources are supplying power. That's, the sampling justification why we have this. Okay, any other question? So you see now, this question takes less time other than the first one because now we're starting to be familiar in how to do the analysis. Okay? Any question? So the overall, when you do any analysis, make sure to assign a voltage polarities and current directions. Assigning this shouldn't take more than 30 seconds or 20 seconds. Then you need to do it in the fast way. Later, the next thing, which is you need to find, after assigning voltage, currents, voltage and polarity, start from the extra given information. Then do KVL, KCL, Ohm's law, such that there is only one unknown. And don't forget your target. You don't need to calculate all of the currents. You don't need to calculate all of the voltages. Your target is to calculate a certain value. So you need to aim your targets, try to solve something around the targets. That's why when I did here analysis, I said we need to aim about the target IA, so we have either node 1 or node 2 to do KCL. So I said node 2 we have 3 unknowns, while node 1 we will have 2 unknowns. So I think let's make our aim on node 1. So node 1, since we have 2 unknowns, then we can calculate I1 If we figure out to calculate I1, then we can solve the answer. And that's the way that we are thinking. Okay? And you need to keep in mind there is no unique solution for this. I mean, here I try to choose the easiest way. Some other maybe can solve it in different ways by trying to find I2, try to find I3, and do KCL on node 2. That can be fine, that can be correct. But the situation, you need to look for the answer in the shortest way and less efforts. I don't want you to spend too much time, spend half an hour in a small question. Okay? So our target is not only to solve the problem, it's to solve it in shorter time, less efforts. And also, if you can make some shortcuts, you can do it. So, as when your colleague asked me if we can substitute V3 directly by I3 times R3, this can be as a shortcut, so you can save more time. Because the question didn't ask you to find V3, and you can skip one step. In case if you find this can be possible. If you cannot, do whatever more convenient for you. Okay. Now let's start the DC mode. DC mode stands for direct currents, which is something fixed with time, or we call it time invariance. Something does not or cannot be changed with time. So most likely, DC, if I have a certain current, like here is I of t, here is t. For example, the current is 5 amperes. It's 5 amperes now. After 1 minute, 5 amperes. After 1 second, 5 amperes. 1 millisecond, 5 amperes. 1 microsecond, 5 amperes. It will not be changed at all. And an example for it is the battery. Try to measure the battery now, 12 volts, something like that. 12 volts. Then after 1 hour, 12 volts. After 12 volts should be around this value. Even though sometimes there's some small variations depending on state of charge or the weather or something like the battery health, but whatever, it should be constant. Okay? So it provides constant voltage, like a battery. Or any source that provides constant current or constant voltage, this is called DC, direct current, or like something constant, time variant. While AC, something changing with time. It can be, for example, like this. Something changing with time. So it can be changed within 1 second, 1 microsecond, 1 millisecond, something changing. Then, of course, we call it like, since it's function of time, I of t, then it will be AC. While DC, as a shortcut, instead of saying I of t, it will be I, and it will be uppercase. And instead of mentioning V of t, it will be V uppercase. So all of them are uppercases. Whenever we solve in DC, everything will be uppercases. And the other thing, which is, let's go back here. These examples, you can look at the voltage source, 4 volts. Look at the current source, IA, and we figure out it was 6 amperes. And the same as these examples. So you will realize the previous 2 examples are actually DC. So these are applications of DC. So therefore, what we have learned so far in DC, all of these are DC. AC will be something different, will be as function of time. Let's recall when I discussed an example of the circuit elements, like the voltage, the relationship between the voltage and the currents for resistor, inductor, capacitor. There was an example with it. That example was AC. Like it was 10 e power negative 5t, something like that. Since it was function of time, that was AC. While otherwise, all of what we have discussed so far are based on DC. Again, I can know this circuit is in DC by looking at the voltage source, the current source. If all of them are constants, then this is DC. And again, what we have learned so far, everything in DC. While AC mode will be in another chapter, we will discuss this later. So the only thing that you are required to know about the AC, which is what you have learned about the circuit elements by applying Ohm's law, or like resistor or inductor or capacitor. Otherwise, everything in DC. Let's recall the values V equal L di by dt. And in DC, I is constant. And again, we will call it as I, uppercase. So this will be as L d by dt of the current I. Since I is constant, it will be 0. Therefore, the inductor in DC, so here is the symbol of the inductor, this is point A, this is point B. In DC, the voltage AB will be 0. There is no voltage difference, therefore it will be replaced by short circuit. Something called like short circuits. SC as short circuit. So the inductor in DC will be short circuit. How about the capacitor? The capacitor, the voltage is constant. And it is V as uppercase. So it will be as the current will be C d by dt of uppercase V, which will be 0. Therefore, the capacitor, it's the opposite of the inductor. Since the inductor is short circuit, the capacitor will be open circuit. Since the current is 0, then we can satisfy this by making open circuits such that I equals to 0. So the current will not flow. Okay? As a result, whenever you have any inductor or capacitor in a circuit, in DC circuits, just replace them by short circuit and open circuit. Okay? So you don't need to worry about any other elements or any inductors, any capacitors. Actually, this is also can be helpful for us. So there will be no differential equation. There will be no derivative. So we will not use the differential equation techniques because there is no time derivative. The circuit elements, basic circuit elements, are voltage source, current source, resistor, inductor, capacitor. That's what we have learned, right? In DC circuits, voltage source remains as is, but it's constant. I source remains as is, it's constant. Resistor remains as is, it's constant. Inductor will be short circuits, capacitor will be open circuits. That's what we will do. And of course, in the resistor, we can apply Ohm's law, V equal I times R. So it's a linear relationship. We will make the life much easier. So we can apply our analysis like what we have applied in the previous two examples. Okay? So in DC, the life is good. There is no complexities. The only elements that you will have are resistors, resistors, voltage source, current source. That's it. You will not see any other elements. So again, by looking at the previous two examples, what are the elements that we have? Current source, voltage source, resistor. That's it. Here, current source, voltage source, resistor. That's it. Okay, now the question is, how about when I have this circuit, but there is inductors and capacitors? What should I do? I know in DC, the inductor will be short circuit, capacitor will be open circuit. How about when I see this circuit, and what should I do? I mean, it's DC. There should be only 3 elements: resistor, voltage source, current source. What you need to do is
start by taking out the inductors and capacitors.
Yeah, replace the inductors and the capacitors by their equivalent circuits, which is any inductor will be short circuits, any capacitor will be open circuits. That's what we need to do. Okay, so actually one of the tests I bring this question, and many students fail in this because they say, okay, it's DC and there's inductor. Sure. How can I solve this? Again, the key is remove any inductor by short circuits, any capacitor by open circuits. So since it's DC, and if and only if DC circuit, if it is AC, we cannot apply this. We will do another techniques that we will learn next month. But in DC, we will do this. Since it's DC, any inductor will be short circuits, any capacitor will be open circuits. So I'm gonna redraw the circuit by applying these techniques. So let me redraw the circuits here, plus, minus, plus, minus 100 volts. 4 ohms resistor remains as is. 10 ohms resistor remain as is. How about the 1 milli? It is 1 millihenry. It is inductor, so it will be replaced by short circuit. Then 12 ohms remains as is. We have the capacitor 100 microfarad will be replaced by open circuit. Then 7 ohms resistor remains, no change. The 5 millihenry will be replaced by short circuits. Then next, the 8 ohms remains, no change. Okay? So before doing any analysis, you need to do these shortcuts. After that, we can simplify the circuit more. How? Look at the 12 ohms resistor. Now, is there any current flowing to it? Recall, the current needs voltage difference and closed path. Voltage difference can be found from the source. Is there any closed path for the 12 ohms resistor? No closed path. So here, current equals to 0. How about the voltage? Let's apply Ohm's law. V equal I times R, which is 0 times R, which will make it 0, right? Now we have for the 12 ohms, both V equals 0, I equals 0. So what should I do? Erase it or neglect it. Whenever any elements, both the voltage and the currents are zeros, then neglect these elements. Erase it from the circuits. This happens if and only if two quantities are zeros, both voltage and the currents, not one of them, two. Again, why two are zeros? It's open path, there is no current to flow, so the current will be 0. Let's apply Ohm's law for the voltage. I times R, 0 times R will make it 0. Then that's it. So the next thing, I'm going to simplify the circuits more by erasing this element. So 100 volts, 4 ohms, 10 ohms, 12 ohms has been removed, 7 ohms. Then I don't need to draw the short circuit because it's already been in the circuit, so 8 ohms. Now, the circuit like this. Okay. So, the question here says find the equivalent circuits. The equivalent circuits, I think if you remember from physics doing the parallel and series, so our target is to get 100 volts here and finding something called R equivalents. So we have this. So basically, we will look at this part, try to find equivalents. Try to find R equivalents. In other words, we will look at this part. 4 ohms, 10 ohms, 7 ohms, 8 ohms, and we need to find R equivalents. How can I find this? R equivalents, you can apply the same principle that we did in physics, or we will learn some techniques on how to do it. But overall, you will see that these two are in series. So 7 plus 8 are in series. Then they will be in parallel with 10. Then it will be in series with 4. So the answer, I think, will be 10 ohms. How we do this? Next lecture, we will explore more how to do series and parallel. And don't forget